All right, in this video we are going to look at some word problems for 5.4c. 5.4c is actually looking for numerical patterns. We're typically going to see those patterns either in the form of y equaling, in this first problem for example, y equaling x times a number, or like in the second problem here, y equaling x plus a number. And on STAAR, those are probably the only two patterns you're really going to see. We're only going to be dealing with one um, operational step. These equations will just be one-step equations that you'll see. There is a two-step question on here. That's kind of a bonus to get ready for next year. So we're going to go get started. Number one, and there's two types of problems that you're really going to see when you're given a problem where you're given these function tables as answer choices, and we have a similar problem in number two where we're given function tables as answer choices. What you want to look for after you read the problem, and number one, the question is pretty simple. It just says which table could represent the equation um, y equals 7x. So that's pretty straightforward. Not a lot of decoding that needs to go on there. And so the first thing you want to do after you read the question, you kind of understand what it's asking for, is you want to look at the x inputs for each answer choice. And what we're looking for is, are the x inputs the same? And what we find on this question is that they are. So my x inputs are going to be 5, 10, 15, 20, and 25. And they're going to be that for every single answer choice. Now that actually makes the problem a lot easier to deal with. Because then when we're figuring this out, if our input is 5 on all of them, if our first x input is 5, then we're going to do y equals 5 times 5. I'm sorry, 5 times 7. Let me change that up to 7. Y equals 7 times 5. And so y is going to be 35. So I know my first output should be 35. Well, it's not on A, and it's not on D. So I can immediately eliminate those as answer choices. All right, so then I'm left with B and C, and I can actually go through and just find where the outputs are different. So I see here that the outputs for 10 are both 70. The outputs, we're going to skip 15 because it's different, but the outputs for 20 are both 140. The outputs for 25 are both 175. So really the only other input I need to work is y equals 7 times 15 for this 15, because this is where they're different. Everywhere else they're the same. So then I just do and I'll just do the computation kind of off to the side here. 7 times 5 is 35. Carry the 3. 7 times 1 is 7, plus 3 is 10. So I get 105 as my output. So that's correct for B, but not for C. And so this one, it's more eliminating, and I only had to do two computation steps, which is good because that reduces my chance for an error. Now number two is much more challenging. Now the first challenging part of it, and you'll see this a lot, is you're given a lot of text in the question. Students earned extra points on a science test for correctly answering a bonus question. The relationship between the student's original test score and their final test score, including the extra points, can be represented by the equation y equals x plus 25. Which table could represent this relationship? Now here's the interesting thing about this. The only thing we really need is the rule. Because all of this text is just explaining what the rule means. That this is their original test score, these are the bonus points, and so this is their new final score. But we don't really need all that because we're not asked to come up with the rule. We're given the rule. We're given y equals x plus 25. So I hesitate to call this extra or unneeded information because it does explain the rule, but we really don't need all of this. And it's really there not to trip you up, but it's there to see, can you pick out the important information that you need from the actual question. And the information we need is just the rule. Can be represented by the equation. All right. So for each of these, now this is, again, much more challenging than number one, because if we look, our x inputs are not the same. So what we have to do then is we have to eliminate each answer choice one at a time based on doing the computation for each of them. So for each of these, I'm gonna add 25 because that's my rule, y equals x plus 25. And then I can just eliminate answer choices that don't work for either one or more of the inputs. Now sometimes, you know what, I really should have put that over here, but that's okay. Sometimes it's obvious to eliminate an answer choice. For example, if we look at G and J, if I add anything to 70, it's certainly not going to be a number less than 70. And the same thing over here. If I add anything to 70, it's not going to be less than 70. So I can eliminate those two. Because these numbers the outputs are actually smaller than the inputs. Well, this is an addition. This is an addition rule. It's an addition pattern. So that's not going to work. I know those two right off the bat are not going to work. So I'm left with F and H. So 65 plus 25, that does give me 90. 70 plus 25 does give me 95. 78 plus 25, I'm not sure on that one, so I probably want to put pencil to paper. And some of these, if you can do them in your head, that's fine, but don't be afraid to put pencil to paper on this. Okay, so that's good. 85 and 25, 110, that's correct as well. All right, so all of these are correct for F, unless I made an error, which is very possible. So let's check H just to make sure. So 72 plus 25, 95, yes. 80, 25, 105, yes, that's correct. I'm not sure on this one, so let's check that one. So 83 plus 25, 8, 10. So that does not work. That's a problem. All right. And then this one's correct. So just this one input, the third input and output for letter H, made letter H incorrect. So F is my correct answer. All right. Now another type of question that you'll get, and you're not usually asked to come up with an equation for it or to write an actual rule, but you're just kind of looking at an input-output table and then decoding what's happening. So in this one, explain what expression would help find the output of the table below. So we're given the input and the output. We have to figure out what's happening from here to here, and that really becomes our expression. So to get from 2 to 4, there's a couple of operations that can get us there. We could either add 2, 2 plus 2 is 4, or we can multiply by 2. All right. To get from 4 to 8, we would either add 4, or we would multiply by 2. To get from 6 to 12, we would either add 6 or multiply by 2. And what we're looking for is we're looking for a common rule. We're looking for something that will work every time. So this addition rule is not going to work because it's not adding by 2 each time, or 4 each time, or 6 each time. So this rule doesn't work. It has to be something that will work for all inputs and all outputs. And so then we're looking for a sentence that works for it. So add 2 to the input, that only works on number 2. It doesn't work on the 4 and the 6. Subtract, we're not subtracting. Dividing, we're not dividing. We are multiplying the input by 2. All right, number 4. Now, number 4 is tricky because it really becomes a reading comprehension problem pretty early on. So the first thing we do, and it tells us, study each table below, and then which statement about the tables is true. So when we're looking at these tables, we're given 4 inputs and 4 outputs for each table. And so what we want to do is we want to mark these up and figure out what's going on each time. So from 30 to 29, the input to the output, it actually went down by 9. Same here from 31 to 22, same here from 32 to 23, and same here. So we're subtracting 9 each time. Now it doesn't ask you to write out the rule or the formula, and it's fine to just say, we're subtracting 9 each time from input to output. For table B, we're increasing by 9. So 17 to 26, we added 9. 18 to 27, we added 9. 19 to 28, we added 9. 20 to 29, we added 9. So now I have to look through and figure out which one of these statements matches what's happening for these tables. And there's a couple of keywords you want to really key in on. Only, both, and neither. So on the only, it's saying only table A is going to do something. So let's see. Only table A shows an addition pattern between the input and the output values. Well, table A is a subtraction pattern, so that's not going to work. Only table B shows an addition pattern between the input and the output. Well, table B does show an addition pattern, and table A doesn't, so this could be a possibility. But let's look through the rest of our choices. Both tables show an addition pattern. Well, we just set up here that table A does not, because it's a subtraction pattern. Neither table shows an addition pattern. So we've already said table B does in fact show an addition pattern. So that doesn't work. So G becomes our answer. This next one is the bonus question. Which table could represent the equation y equals 3x plus 5? This is the one I was talking about earlier in the video because it's actually a two-step. We've got a multiplication step and then an addition step. But the inputs are all the same and they're pretty simple inputs. So for each of these we're going to multiply the input by 3 and then add 5 to it. So because they're all the same, I'm actually just going to kind of off to the side here do each of these. And then I can eliminate as we go along. Now I didn't do the 3 times 0, and the reason why is because anything I multiply by 0 is going to give me 0. So this part's going to be 0, and then 0 plus 5 is just 5. So I guess I could go ahead and write that out. It's not going to hurt anything. So we get 0 plus 5 is 5. Alright, so A doesn't work because the output for 0 is showing 0. B doesn't work because the output is showing 8. Alright, let's go on to if x is 1. So if x is 1, we get 3 times 1 is 3, plus 5 is 8. So that's true for both C and D. So they're still in. 3 times 2 is 6, plus 5. So from my 2 input, we're going to get 11. Still both good. For my 3 input, 3 times 3 is 9, plus 5 is 14. Still good. And then for my final input, 3 times 4 is 12, plus 5 is 17. And so D ends up being my answer just because of this input here. Now the other thing we can do is once we've eliminated A and B, I didn't necessarily have to do all these because if I look, these are the same, these are the same, and these are the same. So really the only one I care about is this last input where they're different. And so I probably could have gotten away with just doing this one, and then just doing this one. I probably could have gotten away with that and still gotten the correct answer. But again, even though this was 2 steps, it was still a pretty simple equation to work through because we're just dealing with single-digit whole numbers. All right, the next set of problems, and I'm going to work through these pretty quickly. Mostly, I'll talk through the first one, but there's just a lot of repetition on this. So I'm going to talk through the first one, and then I'm just going to do the rest, and you can check your answers on here. We're given a function table, and basically what's happening on this set of questions is we're combining this equation and input-output table and function skill that we've been working on. We're combining that with graphing the points that we get as a result. So the first thing we want to do on this is we want to complete the function table. So I'm given the rule y equals x plus 3, and then I'm just going to complete this. So if x is 0, y is going to be 3. If x is 1, y is going to be 4. If x is 2, y is going to be 5, and if x is 3, y is going to be 6. And so now what I have is I have 4 points that I can plot. I've got 0, 3, 1, 4, 2, 5, and 3, 6. And that's how those two things are connected. All right, so my x is first, so x is 0, y is 3. That point will go right here. X is 1, y is 4. X is 2, y is 5. X is 3, y is 6. And so those are my points. All right, like I said before, I'm just going to go ahead and go through this, and I'll make sure that that everything is in the frame. But I'm going to go ahead and do these pretty quickly. If you need to pause the video or slow it down to go back and look, you're welcome to. But I'm just going to knock these out pretty quick, and hopefully I won't make any mistakes. And I'll leave it in the frame for a second or two if you want to pause to check your work. I will say on this one, remember that my 0.5 is just 1/2, so this is 0.5 right here, and this is 1.5 right there, in between 1 and 2. One last thing I want to mention is when we have a multiplication pattern, when we have a multiplication rule, like y equals 2x or y equals 2.5x, excuse me, or y equals 3x or y equals 0.5x, notice that if I've got 0 as an input, I'm going to have 0 as an output. And so when I actually plot the line that goes with these points, because these points will all create a line, that line's always going to go through the origin if it's just a multiplication step, because anything times 0 is 0. So if my input is 0, my output's going to be 0. All right, on to the last page. And we have two questions that are pretty similar to one another on the last page. The only difference is the rule. And this is a pretty tricky question, all right, because, well, we'll just read it and I'll explain why it's tricky. The ordered pairs for the points on the coordinate plane that satisfy the equation y equals x plus 3. Which of these tables shows the other points that satisfy the equation? Now, here's the really important thing to key in on this, is this word other. Because since we have a not here answer choice, if we're not careful, students will look at these points and say, okay, here's 0, 3, and 1, 4, and 2, 5, and 3, 6, and they won't see these points anywhere in these tables, and they'll pick J, and they'll be wrong. Because this is not asking for these points. And in fact, this coordinate plane really is extra information that could potentially trip you up. So the best way to deal with this is to ignore the coordinate plane and just focus in on the rule and our inputs and outputs, just like we've done with the previous problem. So I'm actually going to kind of scribble this out because I don't care about that coordinate plane for this question. All I want to know is which of these tables will satisfy this rule, this equation. And I'm going to do that the same way I've done the others. Now, so the first step, I'm going to look, are my X inputs the same for each answer choice? And they are not. So I'm going to have some computation to do. So each of these, the X is just going to be adding 3 to it. So 4, if X is 4, Y should be 7, not 6. So F doesn't work because Y is going to equal 4 plus 3. So Y would equal 7, not 6. So that's wrong. For G, if X is 12, Y would be 12 plus 3, and so Y would equal 15, not 9. So G doesn't work. All right, let's look at H. So if Y equals 9 plus 3, because X is 9, Y would equal 12. All right, so that's good. If Y equals 12 plus 3, Y would equal 15, so that's good. Y equals 15 plus 3, Y would equal 18. That's good. Y equals 18 plus 3, Y would equal 21. So that's good. So H is my correct answer. Now this is very tricky because coordinate planes and points and equations and function tables, those are all connected to one another. But on this particular question, I don't need the coordinate plane. And it actually serves as a distraction that if you're not reading carefully, students will choose, hey, these points that are on this coordinate plane, they're not here. But if they don't key on this word other, then that's going to cause them to miss the problem. Oop, I was out of the frame on some of my computation there. All right, number 13 is a very similar problem. Um, the difference is just we have a multiplication pattern instead of an addition pattern. And again, this goes back to something we were talking about earlier. We're given this big paragraph, but all we really need is the rule from it. Deanna earns $2 for each dog she walks. She writes the equation y equals 2x to represent her earnings, where x represents the number of dogs she walks and y represents the amount of money she earns. The order of pairs for the points on the coordinate plane below represent the possible number of dogs walked in Deanna's earnings. So again, that's a lot of information, but then they give us the rule. So I don't really need that information up there. And again, I don't need this coordinate plane. It just serves as a distraction because I'm going to look at 1, 2, 2, 4, 3, 6, and 4, 8. And I'm going to think, oh, hey, those are the points, and I don't see them here, so it must not be this. Well, that's wrong because that's not what the question is asking. It's asking for the other points that go with this rule. So then I've got to go through and say, okay, 6 times 2, that should give me 12. Well, that's not right. 7 times 2 should give me 14. Ooh, that looks promising. 9 times 2 should give me 18. 11 times 2 should give me 22. 15 times 2 should give me 30. So maybe B. Let's look at C. 6 times 2 should give me 12. That doesn't work. So B is my correct answer. But we've got to read these very, very carefully and key in on some of those important words that really change the question entirely.